As we know, there are many types of force in our human's life, like the gravity, frictions, tensions, and momentum. But wait, what is momentum? Well, let's talk about collision first. The collision is a noun that describes two objects impacting each other. During this time, the momentum is happened. For instance, one guy is using Kung Fu to hit another guy by using his foot. So at this time, when his foot hits right on another people's face, the momentum is happened. Because of the momentum, the shape of molecule and the molecular bonds on that person's face is changing. Well, we can use a formula to describe the momentum, which is momentum equals to mass times velocity. Moreover, impulse is the rate of change of momentum. It is the area under the function curve between T1 and T2.
A collision is a short duration interaction between two objects, usually between 1 and 10 milliseconds, or 0.001 to 0.01 seconds. If A bounces off B, the force of A on B and force of B on A are action V.
Then, there is an easy way to show the amount of changing in the momentum by using momentum bar chart. Well, as we know, there are some connections between momentum and the Newton's law. Alright, let's get back to the Newton's law.
According to Newton's third law, force of A on B has equal magnitude to force of B on A. An impulse force is when a large force is exerted from a small interval of time. Because an impulse force is a function of time, we can write it as f of x of t. Newton's second law, we know f of x of t equals the mass times the derivative of velocity. The product of a particle's mass and velocity is called momentum, which is equal to the mass times velocity.
We can define the total momentum is sigma I starts from 1 to n momentum in the system dp over dt equals to sum of f1 on 2 and f2 on 1 and plus the sum of external forces. But note that the f1 on 2 and f2 on 1 is equals to 0. So, the net force is sum of external forces. In an isolated system, the sum of external force is 0, so the sum of momentum does not change. In addition, we can use formula to describe this. P final is equal to P initial. For now, we just finished talking about elastic. Now let us focus on the inelastic. In elastic, there are no conservation of energy, and there is something which is not allowing the behavior of elastic. For instance, bullet is getting to the block, and the block is keep forward with bullet. But the interesting point is initial of the total momentum equals to the final of total momentum. On the other hand, initial of the total energy is not equal to the final for the total energy. Alright, let's jump to the explosion. During the explosion, the momentum of the particle cancel each other since they are pointed in opposite directions to the center of masses. The center of mass is just a point in the space. The total of the system is equal to 0 because it was 0 at the beginning. There are forces causing these motions, but they are internal. The last one is the momentum in two dimensions. For instance, in a pool table, there are momentum vectors. In this type of situation, we could be asked for the velocity with the direction, so the conservation of momentum is needed.
A 200-gram baseball is thrown at a speed of 40 meters per second. It is hit straight back toward the pitcher at a speed of 60 meters per second. The interaction force between the ball and the bat is shown in the graph. What maximum force, Fmax, does the bat exert on the ball? What is the average force of the bat on the ball? This is the graph showing that the Fmax is over a time of 5 milliseconds. This is a drawing of the interaction, the bat ball going at a negative 40 meters per second towards the bat with a mass of 0.2 kilograms, and after with the bat with a final velocity of 60 meters per second in the positive direction. The delta P equals impulse force, which equals the area under the force curve. Momentum initial equals mass times velocity initial, which equals 0.2 kilograms times negative 40 meters per second, which equals negative 8 kilograms per meter, 8 kilograms times meters per second. The momentum final equals momentum mass times velocity final, which equals 0.2 kilograms times 60 meters per second, which equals 12 kilogram meters per second. The overall change in momentum equals the momentum final minus the momentum initial, which is a 12 minus a negative 8 equals 20 kilogram meters per second. So the impulse force, which is the area under the curve, equals 1/2 times Fmax times time, which is 0.0050 seconds, which equals Fmax times 0.0025 seconds. The 20 kilograms meters per second equals Fmax times 0.0025 seconds. So Fmax equals 20 kilogram meters per second over 0.0025 seconds, which equals 8,000 newtons. The average force with delta T equaling 0.0050 seconds, F average equals impulse force over delta T, which equals delta P over delta T, equals 20 kilogram meters per second over 0.0050 seconds, which equals 4,000.
I hope you guys can enjoy this video, and I hope you guys can remember the beautiful word momentum. If you like this video, don't forget to